So in this video, we're going to be learning about exponents, right? So laws of exponents to say. But before we dive into the laws of exponents, I really want us to dive into an anatomy of an exponent. Basically, what an exponent is and how it's constructed. So the first thing that I want us to talk about is what we call a base, right? So a base is basically this right here. This A is known as a base, right? And what's on top of it is our exponent. And then the combination of the base and the exponent is what we call a power, right? So this will be, let's say this base would be 2. And then our power would be, well, our exponent would be 4. So we'd say base 2 to the exponent of 4, or uh, uh, um, 2 to the power of 4. So those are kind of the terms I really want you to understand. When they say power, they're referring to the whole thing. Exponent is this, and obviously the base is the one at the bottom, right? So now that we understand the anatomy of an exponent, let's really dive into the laws of exponent, right? So the first law that we're going to talk about is multiplication rule, right? So this rule says if we are multiplying powers, which is the whole thing, in this case it would be a to the power of x multiplying by a to the power of y. If we're multiplying powers that have the same base, what we do is we need to add the exponents, right? So we add the exponents. So a to the power of x multiplied by a to the power of y would be equal to a to the power of x plus y. So let's just make that a bit more practical, right? So we have 3 to the power of 2 multiplied by 3 to the power of 3, right? So what that means is that we're going to say 3 to the power of 2 plus 3, which is the same as 3 to the power of 5. Right? And if you really want to check if the answer is correct or if it's the same thing, we know that 3 to the power of 2 is 9, 3 to the power of 3 is 27, 9 times 27, that will give us, let me just quickly get my calculator, 9 multiplied by 27, that will give me 243, 243. And I know that 3 to the power of 5 is the same as 3 times 3 times 3 times 3 times 3. And it's the same as 9 times 27. If I take these two, they're going to give me 9. If I take these 3, they're going to give me 27, which is basically the same as that. So the answer is basically the same, 243. So that's what it basically means when we say if you're multiplying powers that have the same base, you don't even have to think of anything else. Just add the exponents if the base have the same value. Alright, so let's just erase this and look at our other example. Quickly erase this. Okay, so let's look at our second law. So our second law says basically the opposite of what we just did. It says if we're dividing powers that have the same base, if we're dividing powers, which is everything here, that have the same base, what we need to do is we need to subtract the exponents. So in other ways, if we had the very same 3 to the power of 3, all divided by 3 to the power of 2, what we need to do to find the value is we're going to say 3 to the power of 3 minus 2, and that will give us 3 to the power of 1, which is the same as 3. So other people would have said 3 to the power of 3 is 27, all divided by 9, and we don't know how many times does 9 go into 27. It goes 3 times, so we know that the answer will be 3. So that's what basically our second law insinuates. So these are two of the most important laws that you're probably going to be seeing more often, and we just need you to grasp them so we know moving forward how to apply them, right? So the third law says power of a power rule, or power of a power law, right? So this one says if we have an exponent or we have a power inside a bracket and outside the bracket we have an exponent, this exponent that's outside the bracket will multiply the exponent that's inside the bracket. It won't multiply the base, it won't do anything to the base, it will just multiply the exponent. So in other ways, if we had 3 to the power of 2 multiplied by 3, the exponent of 3, this would be the same as 3 to the power of 2 times 3, which is 3 to the power of 6. 3 to the power of 6. Yes, so 3 to the power of 6, I don't know what the value is, but that's basically what that law insinuates, or that law means, right? So let's move on to the next law. So the next law says power of a product rule. So now we have two powers or two bases inside a bracket, right? And then outside the bracket we have x. So I just need you guys to always keep in mind, if I write b is the same as b to the power of 1. If the power is 1, we always don't write it, we'll just write it down as b. So I need you to keep in mind, every single time we see something like this, a always insinuates that it's a to the power of 1, and then this will be b to the power of 1. So if something is written as ab, it's the same as a multiplied by b, right? It's the same as a multiplied by b. So now we have an exponent outside the bracket, which is to the power of x. What that means is that this exponent will multiply this one here and this one here. So our value would be a to the power of x times b to the power of x as well, right? So that's what power of a product rule basically means. Let me just use this one. So the next law that we're going to be talking about is power of a fraction rule. So this one basically works the same as this one. So remember, a fraction is just two numbers dividing each other, or two values dividing each other, right? So this one was two values multiplying each other, this one is two values dividing each other. So now if we have two values dividing each other and an exponent outside those two values, these two values are inside a bracket. Let's say, for example, we have 3 to the power, or 3 over 4 to the power of 2. What this means is that it will be 3 to the power of 2 over 4 to the power of 2. Remember, as I said, if I write something as 3, it's the same as 3 to the power of 1, right? 3 to the power of 1. So now, if I say 3 to the power of 1 multiply, or to the power of this also exponent outside, this is the same as 3 to the power of 2. And same applies to the base. 4 to the power of 1 would be equal to 4, 2. And then all over each other, right? So if you were to leave your answer, I think they'd want you to leave your answer in this way. You'd say 9 over 16. So that would be your final value. But that's what basically this law insinuates. It's basically the opposite of what a product rule says, right? So before we move on to the zero exponent law, I want us to cover a very important law which will guide us into understanding why a to the power of 0 is always equal to 1, right? So we have this law that says if I have a to the power of a negative number, and we're gonna obviously have that number as a placeholder, as a variable m, and then a to the power of negative number will always give us the value of a to the power of 1 over a to the power of m. So what we do is we take this whole product and say 1 over that whole product, and then basically we just change the sign into a positive sign. So that's what basically that means. So in other ways, if we had something like this, 2 to the power of negative 1, that value would always be 1 over 2 to the power of 1, right? So this is one of the laws of exponents that's really not on this page, but I want us to cover it before we can move on to this one so that we understand how that one works, right? So keep that law in mind, right? So now what we have is we have this law that says a to the power of 0 will always be equal to 1, right? What they don't say is that this law is only valid if a is greater than 0 or a is less than 0. right? If a is 0, then this law is not applicable. If a is 0, that law will not be applicable. A cannot be equal to 0, right? So we know that in our second law, we know that if we're dividing powers that have the same base, we subtract the exponents, right? So let me just rewrite a to the power of 0 as 1 minus 1, right? And we know that a to the power of 1 minus 1 is the same as a to the power of 1 multiplied by a to the power of negative 1. We can also apply that with the first law. Actually, let's use the first law instead of the second law. We know that a to the power of 1 minus 1 is the same as a to the power of 1 multiplied by a to the power of negative 1, right? If we break it down. And a to the power of negative 1 is the same as 1 over a to the power of 1, right? So now we know that these two will cancel out and we'll have the value of 1 left. So always know that if we have a value which is a to the power of 0 is equals to 1, any value that's a to the power of 0 will always be equal to 1, only if that value is not 0. Only if that value is not 0, right? So let me just erase this so that we can cover the remaining laws of exponents that we have. I'm sorry about this. I actually just started using this platform to record my videos, so I haven't really gotten accustomed to it. I'm sure there's a better way of erasing stuff, but yeah, I haven't really gotten accustomed to it, right? So another law of exponent is called fraction exponent rule. So it goes like this: if I have a power like this, m over n, I can better write it as n, and then we square that a to the power of m, right? So let's just rewrite that using numbers to understand what that means. If I had something like 2 to the power of 3 over 4, right? 3 over 4. Actually, let me just say 3 over 2. Let me just say 3 over 2. 3 over 2, right? This would be the same as me saying 2, which is like a square root, 2 to the power of 3. So that would be 2 here, and then this would be 8, and obviously this would be my answer if I was to leave it in surd form, right? Yeah, this would be my answer. Actually, that would not be my answer if I was to leave it in surd form, but yeah, that's what basically that rule says. If you have a to the power of m over n, that over m will be what replaces the value here on the square root,